just use this solely as reading the analog output. Digital inputs, if I have to tie the digital input to, if it's an event, digital input 1 or 2, data acquisition enable. Let's see. Enable on these access points occur.
I'm going to say the supply current 20 milliamps and 7 volts DC.
But that's what it draws. That's what it's saying it draws.
What do we set the voltage as? Excitation 10.
10. Yep.
So at 7 volts, 20 milliamps. What time is your flight tomorrow?
I think I'm at 8 a.m.
8 a.m.? Oh shoot,
Yeah.
you got plenty of time left. What did you see? Oh, are you on the phone? It doesn't make any sense why this would have digital input.
Oh, there we go. Digital input from low to high. So this event occurs when we want to set. There it is. Data acquisition enable. Okay. Okay, data acquisition input, digital input low. And this. So you're going to want to see how I've done this because it's not on a hardware basis, it's on a test basis. So each
Alright.
test that you want to
You're ready.
execute. Okay.
Okay.
So,
This is for digital input?
yep. Digital input to trigger acquisition. Yep. You could use it for other purposes as well. It's just that this is just set up right now for acquisition. It's not terribly difficult, but. So on the left side of my hardware tree, I've unassigned a couple of channels in the flex stack. I only need one if I want to do enable disable because I've got a digital low to high transition and a high to low transition that I can use. So low to high I can use to turn on acquisition, high to low I can use to turn off. I can split it up into two separate ones and just have a low to high on the first one being a, enable acquisition and then don't pay attention to the falling edge. On the second channel, I could have a low to high be disabled. You can configure it any which way you want. So I went into the hardware tree, I went to the very bottom, and I just unassigned two channels. So I pulled channel 63 and 64, unassigned them from whatever they were assigned to previously, all the sensors that I had. and then I imported them to the current test. So if I imported, all I did was drag and drop into the digital inputs. Now I have digital input 1 and 2 based on those two channels that are on the flex stack. So my test sees those, it's not doing anything with them yet. So to do something with them, we wanted to trigger certain commands. We do so based on events. When you add in these digital inputs, you get by default high to low transition, low to high transition for input 1, high to low and low to high for input 2. If I added more, you get more auto-populated by default. So to configure the low to high or high to low, you double click on the event, and then I've, in the events tab, added the data acquisition enable. So you go to add, and then in commands, you have this list of things that you can do. You can enable, disable, you can do a burst mode scan, you can do time mode scans, single mode scans, change a bunch of different things, or custom command scripts. So all I did was say on a low to high transition, I wanted to enable data acquisition. So I have data acquisition enabled. And then for high to low, I did the same thing, but I told it to disable instead. So on the add menu, under commands, told it to disable data acquisition. So now whenever you would run this test, it would be paying attention to this digital input on a 63rd, 64th channel to enable and disable that acquisition. 63rd channel to enable and disable. So you can set that up for whatever channel. You want to make sure it's the correct voltage input and hit order to enable and disable. So that still goes back to the question of what output you'd want to use or can use from the flex test side of things. Flex stack.
What's considered high? What's it looking for?
Yeah, we can take a look.
10 volts? No, where was that?
I think it's probably more TTL logic level, so it's probably 5 volts or 3.5 volts. Flex stack, digital, smart DIO setup. So low is less than 1.5 volts, high is above 3.5 volts, input range up to 10 volts, plus or minus 10 volts. Yep. So you could do a plus or minus 10 volt, like the analog output from that side, stick on the analog high, and then have that tied to the digital input on this side, and then have that be the start-stop for acquisition. The wiring pins 3 and 4 are the ones we want for the input. And that's kind of the deal. So, not too crazy. You'd still want to have the test loaded, otherwise it's not going to enable that acquisition. So you still got to do setup on this side and be prepared before you start the other test in order to make sure that it would record.
When it gets that trigger, it's like it's immediate, right? It's not like a second or two delay.
There shouldn't be delay. Yep. Yeah, because there's nothing. It should run at system rate. So when I say there shouldn't be delay, it's always, time scale is always a question, right? If it's in between clock ticks, you're going to get some amount of clock tick of delay. If you're operating at, I'm assuming it's running at probably higher than system rate, and you're not going to see anything because it's going to be less than 1 over 6144. But if there is some impact to that system rate, you might have, if it's 256 that you're running at, there may be, let's say, up to 1 over 256 of a clock tick, let's say, that could potentially be missed in between the turn on, if it's only sampling at that rate. And so that still is on a per test basis, so if you were to change to a new test, you'd want to reset up those enable and disable functions.
So when it's all enabled, it's all set up, and it's looking for a trigger mechanism from there, do you hit the run button and it's in suspension?
You load it, load it and let it sit there, instead of, so, is it okay if I save over, or save with this addition to your strain gauges?
Yeah.
Okay, so I'll just, let's save, and then load, back to station one. Oh, that's interesting. Well, it thinks I started it based on my events. So it saw a low to high on 34, which could be because it's floating. Because if I don't have it hooked up to anything, what's the voltage, right? You don't know, I don't know.
I
But,
hope it's not fluctuating that much.
well, if it's floating, it could be 1.5 volts, it could be 3 volts, I don't know, right?
Can
But that's
we-
not a use case, it's.
Can we set it for a particular value?
Nope.
Oh,
It's transistor to transistor logic that it's set up for, so it's.
what
per-
about,
per
what about analog input? And we trigger an output from the 60.
Right, well, this is basically an analog input. It's just that it's triggering at above 3.5 volts. So if you want to recreate the digital input functionality, you can, but it will probably be more difficult to implement and maintain.
So it's dependent on that flex DAC, or not flex, that 60 not floating, and this
No,
one
no.
not floating.
So when I say floating, I mean, you have some electronics hooked up and you're expecting to have something connected on this side that is either high or low, or some voltage. Right now we have air, static, and internal charge buildup on something that is not grounded or is not hooked up to a voltage source.
Right.
If we have that hooked to this, that will be saying 0, 1, 2, 3, 4, 5. Right now, it's charge buildup on an open conditioner. So I can't predict what it's going to be. I won't predict what it's going to be. There's no purpose to have this set in this mode aside from showing you that it's configurable as this input. Otherwise, that would be tied to ground, or it would be tied to an input that would be tied to ground until it is triggered.
So when it's all, when the wires are connected to the devices, that voltage is stable, it's not gonna come out unstable.
You're not going to have a whole bunch of junk in it. You're going to be at, if you're commanding 0 volts in an analog output, you're going to be.
Because if we don't know what it's gonna trigger, what if it,
Well, you don't know when it's going to trigger, you don't know what the voltage is when it's disconnected from anything sitting in open space.
but when it's, even when it's connected and it's still, because it can fluctuate, it can get some noise of a couple
The trigger-
millivolts.
Sure, the trigger level here is above 3.5, it turns on, below 1.5, it shuts off. So you've got a 2-volt window there that if you have that much fluctuation in your cabling, you've got problems. Right? If you're internal to electronics without anything connected to it, again, I can't predict what the voltage levels could be. So. Because typically you'd have, say, pull down resistor, pull up resistor. This is using an analog input as a digital input. It's just, it's internal conditioning. It's saying, okay, if I'm above this level, say I'm on. If I'm below this level, say I'm off. But we don't want to implement, say, a pull up or pull down because now we're using an analog input. If I start putting a pull up or pull down in, I'm going to screw up my analog input. So it's a smart DIO. Use what's available there. Use the ADC circuitry that's there to provide the digital input functionality without having a dedicated digital input. So you could, for example, if you took the, whatever it was, pins 3 and 4, jumpered them together, and then hooked them back in there, you will have the issue, because you're telling it 0 volts. If you unplug it, now we're back in the scenario of, I have floating input that's picking up whatever charge, whatever is sitting around. I'm not telling it to be grounded, I'm not telling it to be at a certain voltage, it is undefined. Don't operate, don't tie your data acquisition to a signal that is undefined. Same thing with reading from the inclinometer. We need to ensure that our common signal is referenced to something that we care about. Otherwise, we're measuring a floating signal. We can't do a non-referenced measurement, or we can attempt to do a non-referenced measurement, but it's a voltage from a source that is referenced to its common goes somewhere else. We need to measure across those two terminals, or else the signal does one of these, it's around.
Sorry.
So that's the enable, disable setup. Use is having plumbed into something, enabling or disabling. I guess it should be traveling with like a couple AA batteries or something hooked up to a little pigtail so I can go, here we go. We're on.
Yes. I hope we're not going to be doing false triggering. I don't want any trigger happy.
It's not like we would.
No.
I guess we just have to figure out what exactly
The
what we're
output
gonna
is.
output, yeah, what the output's gonna be.
I just do 0 to 10 on that side. 0 I'm off, 10 I'm on. This knows 10's greater than 3.5, 10's within the range of travel. You can't over command 10 on that side, and it's pretty easy to set it up to 10. And this side can handle it.
But what channel do we use those to do that?
Digital output.
Well, I go analog on that side. If you have enough analog, so like you're doing
Just like the one that we have hooked up.
Yeah,
We
just
we
like
tell
that.
it to send out a voltage
Yeah.
and that's in the procedure editor, right?
Mhm.
That's where you'd put in another,
So you can make a probably program only channel and just have it named something, FlexDAC enable, disable signal, FlexDAC something,
Oh,
FlexDAC
okay.
control, and then in your procedure, when you get to the point where you want to enable it, you do a ramp from nothing to 10 volts in 1 clock tick. Do it immediately. And then, all right, now my output's at 10, run my procedure. When I'm done, ramp it again at 1 clock tick, 1 over whatever your system rate is, back down to 0. Then this should see it as a transition back down below 1.5, and then it cuts off. So, but to answer your earlier question, all we do is load this, now it's sitting waiting. If I enable it, I can still enable it, but it's waiting for anything to happen. It waits for the event to happen, it waits for me to enable it, it waits for me to unload it and be done. Anything that can happen in between, could be an event, could be me interacting with it, or anything above.
I'm thinking we just use it like we can use this when we just start this acquisition first and then run the test on the PT.
so you're talking like
No start synchronization.
doing echoing, so the data is echoing off of the load cell? Like we do on the IO Tech?
I see. Yeah, no, let's not do that.
Well, either way, we burn a channel.
How many channels are you typically running with?
Don't ask them, because they'll go with 100. If you have 64, they'll go, oh, we need 65. And you're like,
They just force it this way, so to some extent, sounders.
the most we've used so far is around 42, 43, 42?
Oh, you're talking like total? Oh,
Yeah.
I thought you were just from
So far,
the
but-
flex test.
I mean, we're expanding, so it could change. We'll just get another flex stack.
Or you big test with the 100 channels. I don't think we'll do something similar here. Maybe half of it.
Yeah, I think the most we've ever run has been 42 plus some on the.
I think the max was like, what, 48, but we're only able to use like 38 or 40.
And then several on the 60. We're just trying to figure the best, what's the normal way to synchronize these two together? When they cut in, when they cut out.
That's a question, like, can we just connect our X densometers directly to one of these channels without having to like reconfigure any of the pins?
We'd have to look at your pin altitude accelerometers and see how that matches up on this side.
Yeah, the extensometers think they're full bridge connection.
Okay.
They have plus minus and then plus minus sensor input.
I would hope this would be pinned out the same
The
way.
same, but we don't have any cables.
Yeah.
Or cut off any ends.
We have to make an adapter because they're the Amphenol connectors, the 6-pin round. So we have to make a decision which route we're going to go. If we're going to start using this, we have to change all of the sensors because they're all either just, there's no connector like on the Flex, the IoTech, and then the MTS has got a completely different connector. It's got the Amphenol around, so all the extensometers, they have the round one.
Wait, but the other end is a Ethernet. Or
On that or this. There it's RJ50s. Typically here it's RJ45s.
So
10 pin.
if they're going into the 60, then they're the RJ45s. They're those.
oh,
Well,
I didn't know the
don't-
difference.
Those are RJ50s. Those are 10 pins. These are RJ45s.
Oh,
These are 8 pin. You pull
Eight.
off two more
Eight pin.
pins. I think they're the same width. It's just that they stuff two more pins. I think. I don't know if the spacing is the same, but you want to make sure before you plug an RJ50 in that it, pair up and see.
Yeah, I hope
But if
it's
all it
not.
is two pins off the ends and the spacing is the same, then ensure that the pin out is comparable for the 8 pins that are still there. Usually the pins that are off are like shield and ground sometimes, or shield and something else. The pin 1, pin 10, I thought pin 10 was like typically a shield, but I don't know.
So we have another connector adapter we gotta deal with.
RJ45,
Well, the RJ45s are the typical ones. This is the normal stuff.
Oh, really?
The RJ50s have been unknown to me until I started working at MTS. I don't think a 10-pin Ethernet cable. The world is 8-pin, as far as I'm aware. The whole 10-pin thing, I think, was just so that we could squeeze in more cables, more conductors in the same package for various sensors. Whereas the RJ45s only accommodate 8, and you have scenarios where you need more than 8.
So the cables that are working over there,
do not work.
they won't go in the back here.
I could double check.
We'll count them.
I don't even know what they're
I won't say they won't work, but I'd say check and see.
How would they though? I mean,
Well, if you're not
line up.
using those pins.
Well, if there's no, is there, are you saying the connector's wider?
No, I think the width is the same. because there is some dead space here and here, I believe it's just filling in those last spaces. So if you have a
45, 50,